We're now beginning a lesson where we're learning to solve systems of equations. Let's start with the basics. Let's solve an equation in two variables, and we're going to be using the elimination method. Now, what are we trying to do when we solve an equation in two variables? Well, let's note, when I have just one variable, like we have in this equation, we can solve it for the value of x. When we have an equation like this one where we have two variables, we cannot solve it for a value of x or for a value of y. In order to solve for two variables, we need a second equation so that then we have a system of equations. You must have one equation for every variable. So when I have two variables, I will need to have two equations. Now let's see how we can take a system of equations with two variables and show you how we solve it using elimination. I am going to write out the steps that we will use. You can copy these down, but at least you'll know what I'm doing. First, I will eliminate the x variable. Second, I will solve for the y value. Then number 3, I will substitute the y value into one equation. It doesn't matter which one that we started with. And then number 4, I will solve for the x value. You can eliminate the y value and then find that first, but I'm giving you a procedure where you can do the same thing every time with the same steps. Everything is laid out. You don't have to think, what am I going to do? It's a process, and you do the same thing for every system. That's how we eliminate mistakes in mathematics. Now, if you learn shortcuts, that's great. You will often see shortcuts that you can make. But when I'm teaching, I teach one method that you can follow. All right, let's take our first system, negative 3x plus 10y equals 5, and 2x plus 7y equals 24. And we want to solve this system. Well, the first thing we need to do is to eliminate the x value. So I do this by looking at the coefficients of x and switching them, 2 and 3. 2 times 3 is equal to 3 times 2, always. Then I make sure that one product is negative, 2 times negative 3 is negative 6, and one product is positive, 3 times 2 is positive 6. This will give us these two equations. Negative 6x plus 20y equals 10, and this will give me 6x plus 21y equals 72. One of the things that we can do in a system of equations is form a new equation by adding the equations together. So when we add these together, the x's cancel. I get 41y equals 82, solving y equals 2. So now I know that y equals 2. I can now plug this back into one of these equations. I'll plug it into this one. 2 times x plus 7 times 2 equals 24. This means 2 times x plus 14 equals 24. 2x equals 10, and x equals 5. We often write this solution as an ordered pair, x first, y second. Solution, 5, negative 2. Notice the 4 steps. Multiplying, switching these numbers and multiplying so we can add equations together to get rid of x. Once we solve for y, then we can plug y back into one of the equations to solve for x, and that will give us the second solution. If in this process, sometimes in this process, when we add these two equations together, both x and y cancel out. If that happens, let me make this note. If I have something like 2x plus 3y equals 5, and then I have negative 4x minus 6y equals 12. When I multiply these, I multiply by 4 and 2, and that gives me 8x plus 12y equals 20, and negative 8x minus 12y equals 24. I add these together, and these cancel, and I get 0 equals 44. If this happens, you have a system which has no solution. If I cancel them out and I get 0 equals 0, then I have coincidental lines, and I have an infinite number of solutions. This means that the two equations were originally identical and not really different equations. This means that I had different equations, but there is no solution. If you've looked at the graphing video, this means that the graphs are parallel and they don't cross each other. This means that the graphs are coincidental, one on top of the other, and you have an infinite number of solutions. So there are some strange things that can happen when you're solving systems of equations. Let's look at another one. 3x plus 4y equals negative 1. 6x minus 2y equals 3. Okay, I'm going to multiply by 6 and 3. That one's going to be negative. I get 18x plus 24y equals negative 6. This gives me negative 18x plus 6y equals negative 9. Check my multiplication. 18 plus 6, negative 9, 18, 24, negative 6. Add them together. I get 30y equals negative 15. So y equals negative 1/2. So now I know that y equals negative 1/2. Let's plug it back into the equation above. 6x minus 2 times negative 1/2 equals 3. This means 6x plus 1 equals 3. So 6x equals 2. X equals 2 over 6, or 1/3. So the solution is 1/3 negative 1/2. Now we're going to do a little quiz of 2 problems. I'm just going to write 2 systems and see if you can tell me what you would multiply by to get rid of the x. 3x plus 2y equals 4. Okay, put it on pause and then figure out what you would multiply by, and then turn it back on and see if you did it correctly. All right. Here's what I would be multiplying by: 2 and 3, 3 and 5. Notice this, I'm going to have to make a negative 3 to get a positive and a negative product, and here I have a negative and a positive. So that's what I would use to multiply and then go through the rest of it. Okay, let me give you one system to solve and see if you've got the hang of it. 5x minus 6y equals 10. Negative 2x plus 3y equals negative 7. See if you can solve this system. Put it on pause, solve the system, and then check back to see if you were able to solve it correctly. Okay, I would multiply by 2 and 5. That gives me 10x minus 12y equals 20. It gives me negative 10x plus 15y equals negative 35. When I add those together, I get 3y equals negative 15, y equals negative 5. So now I have y equals negative 5. Now I substitute that back into the equation above. Negative 2x plus 3 times negative 5 equals negative 7. So negative 2x minus 15 equals negative 7. So negative 2x is equal to negative 7 plus 15. Negative 2x equals 8. X equals negative 4. That should be your solution.